Hey you guys, welcome Geometry, Module 3, Topic 1, Lesson 2, page 461. We're talking about establishing triangle similarity criteria. And the first one we're going to focus on in Activity 1 is establishing the angle-angle similarity criteria. I recommend you have all of the materials you see here, from pens, pencils, protractor, tracing paper, sharpened pencil, by the way, and highlighters. You can conclude two triangles are similar, there's a vocabulary word, when you prove that all of the corresponding angles are congruent and all of their corresponding sides are proportional. And so we want to be able to demonstrate without having to go through the rigor, which means like full depth of the content, of establishing triangle similarity, but trying to get away with something a little more efficient than showing everything matches and every side is proportional. Let's use constructions, and there's a formal way for constructions. It's compasses and a straight edge, but we're gonna cheese it with tracing paper to see whether you can use fewer pairs of angles or fewer pairs of sides to show the triangles are similar. Construct triangle D prime, E prime, F prime using only angle D and angle E in triangle DEF. Make all the corresponding side lengths of triangle DEF different from the side lengths of triangle DEF. So we want to make sure it's bigger or smaller. Bigger is easier to draw when we have the tracing paper to do it. So tracing paper in hand, pencil in hand, trace triangle DEF. Now, the pro tip here is to take the tracing paper, turn it over, and trace it again. And I'm using like some scratch paper as a backstop so that when I do my tracing, I'm not pushing, extra pencil lines onto the existing paper. So that is my focus and my hope right here. See what I did? I pushed pencil lines onto that paper as well. Now, tracing paper goes back down, and I'm just going to try to trace the corners. But I'm not going to trace them all at once. I'm going to trace corner D, and then I'm going to use the protractor to make that line. And I'm even going to switch to a pen right now to make that line and that angle longer. Now, I don't know how much longer to draw it, so I'm not going to go too crazy. But I do want to make sure that I'm following like the path of that triangle. And then I kind of look at which one of these lines is shorter. I guess it's this one. So from there, I'm going to move my tracing paper, which fit so nicely in that little shape. I'm going to slide it down so that this angle E corner is now at the end of my trace. And I'm going to get back to the pencil and I'm going to trace it. Even by doing this, I'm technically demonstrating something called angle-angle criterion, because I've created angle D prime that matches angle D, and I'm about to create angle E, E prime that is, that matches angle E. So if you can create two angles of a triangle, the way to finish out the triangle is just to keep drawing this line longer, draw the other line longer until they meet, and when they do, that's your triangle. And it will be similar to the first one. All we needed to create this similar triangle, I'll use the tracing paper to show you how the angles are the same. All we needed to do is just start by drawing two angles from that triangle. And so I'm just kind of working my way back and forth, getting it a little lined up, continuing to open up. See, that's what the triangle triangle similarity does for us. We end up creating two triangles that are actually similar, but the only thing we needed to use to create those two triangles was angle-angle similarity. Now let's just get the quick check in here. Angle D perfectly matches in that section of the triangle. Slide to angle E. Angle E perfectly fits inside the angle E of the other triangle. The real test is, does angle F fit? And so if I slide the tracing paper over the way that I made my triangles, yeah, it fits perfectly the way it's supposed to. Make all the corresponding side lengths of triangle D prime, E prime, F prime different. We definitely did that. Let's go to question 2. Measure the angles and sides of triangle D prime, E prime, F prime, and triangle DEF, and are the two triangles similar? Reminder, to be similar, we have to make a list. Is it true that the measure of angle D equals the measure of angle D prime? Well, if it does, what is that number? Is it true the measure of angle E equals the measure of angle E prime? Well, we're going to measure them both and find out if that's true. And then the measure of angle F, we need to check. Does it equal the measure of angle F prime? I mean, I use the tracing paper to know, but it's kind of nice to have some numbers, and we have the protractor to figure that out. Now, the second part of this, in showing that shapes, triangles in this case, are similar, is to see if there is a relationship, like a scale factor that would be the solution of solving a proportion. Let's see if there is a scale factor that compares DE to D prime E prime, and if that same scale factor is true for the other two sides of both triangles. So I need to know how big DE is, and I need to know how big D prime E prime is. Kind of running out of room. Wish I'd written a little bit smaller. DF, D prime, F prime, and EF, E prime, F prime. So let's get some measurement going. Okay, I'm gonna start with the angles. So in order to measure the angles on the small triangle, which actually, you know what? I'm gonna do one thing. I'm gonna acknowledge that this triangle perfectly fits inside this one. So if I measure the angles here, I already have evidence that those two angles are the same because I have what I use with the tracing paper. I also know that these two angles, E and E prime, are the same because I measured and I checked it with the tracing paper. So instead of like drawing a bunch of lines all over the place, I'm just going to draw lines on this one, and this is what I need to do. I'm going to draw a long line. I'm going to draw a long line. I'm going to draw another long line. So now, with those lines being that length, I can use, like how big the protractor is, I can now actually use it to see where my lines are going to cross on the, numbered markings, the angle markings. Let's measure angle D prime. So the center of the protractor is going to go on D prime. Then I'm going to twist the protractor around. And you could twist it too much. You'd have two measurements. You just subtract the two. But I find it easier to set one of the measurements on 0. Okay, so I'm exactly in the center there. I'm lined up with 0 here. My triangle, this angle D prime has an angle of 40, 5, 6, 7. I'm going to say 48 degrees. I'm going to mark that down on the paper. Angle E is next, angle E. So same thing, it's all of this angle, and I'm going to make the protractor. If I put the protractor center circle on E prime, and if I look at this number out here and this number out here and subtract it, that would be a way to use the protractor, but it actually works better, like more consistently for like, eliminating the math thinking you have to do when you're focused on other things. Put the 0 of the protractor on one of your lines, and then count up 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 100. It's like 105. 105 degrees. Now, with some math calculation, all of the angles in a triangle should add up to 180. So if I take the calculator out and I go 180 minus 105 minus 48, this last angle should be a 27-degree angle. So let's just check if angle F prime is, in fact, 27 degrees. Center of the protractor on F prime. The 0 of the protractor on my line, and then count up 10, 20, 25. It is 27 degrees right here. That's the first check of whether or not two shapes are similar, is to make a list. Now, making this list takes a little bit of time, but it does set up. Now, I'm going to use centimeters and millimeters. Let's go with just straight up millimeters. That's every single little tally mark inside the protractor. So I'm going to measure DE first. And I want to measure DE, and then I want to come over here and measure D prime, E prime. And I want to figure out if there is some like multiple, some scale factor that lets us take the first measurement and move it up to the second one. Okay, DE. From 0, This is 2 centimeters, or in other words, 20 millimeters. Then I'm going to come over to my shape, and I'm going to measure from D to D prime to E prime, and I get 10, 20, 30, 31, 32, 33. I get 33 millimeters. By the way, what I'm writing over right here to think about, did everyone create the same triangle? No, this is my triangle. I made this, I made it of my own size. You probably have a different triangle, so if you're straight copying this video right now, you're kind of doing it wrong. You should be making your own triangle and seeing what I'm doing and comparing it to yours, but I get it, time constraints being what they are. I would recommend that you just make sure that these numbers here are matching your own, because I made them for my shape. Your shape might be just a little bit different. Okay, continuing to measure. I'm on EF, so that would be 10, 20, 30, 31, 32, 33. Ooh, EF is 33. We saw that already on the other side. E prime, F prime, I get 54. Again, that's for my triangle. Yours might be a little bit different. Last two sides, they match corresponding DE. DF here. So sitting there, 10, 20, 30, 40, 41, 40, 44 is the number that I get millimeters. And then last of all, this winds up at being approximately 70 millimeters. So in order to check if we made the two shapes similar enough, I'm going to take 33 and divide by 20. I'm going to take 70 and divide by 44. I'm going to take 54 and divide by 33. That's this number divided by the first one, 33 over 20. That's this number divided by the first one, 70 over 44. That's this number divided by the first one, 54 divided by 33. And I want to check whether or not all of those happen to be the same amount. So, hey Siri, what's 33 divided by 20? Didn't work. 33 divided by 20? 1.65. Okay. 70 divided by 44? 1.6. 54 divided by 33? 1.63. All of my measurements are within a hundredth of each other. The last question is, are these two shapes? There is sufficient information. Yes, angle, similarity is enough to show / create similar triangles. All right, thank you guys so much for watching page 461. Next up, 462. Like, comment, and subscribe. See you in the next episode.